So in the last part, we figured out how to find the sum of squared deviation, really. Squared deviations. That's what I should really call it. I think your book does say squares. All right, squared deviations. And is this really a good measure of spread? 23 points seems awfully big compared to this. And let's say I added 2 points on here. Let's say I added a 4 and a 5. And I'm picking those on purpose. Why did I pick them? Well, our average was 4.5. So if I had a 4-slice kid and a 5-slice kid, have I changed the average? No. And what will happen is I'll add another negative 0.5 and I'll add a positive 0.5 for the 5. This will still add up to 0. But this is going to get a little bit bigger. So be penalized for having more points. Actually, a lot of points in statistics is a good thing. So we need to figure out how to fix this for however many points we have. Otherwise, I have to write the rule, oh, everyone must use 6 sample points. And that doesn't make sense. So how can we correct it for the number of points? Well, we can sort of divide by the number of points. Now, hold on a second. This works for populations. But when we're dealing with samples, for a technical reason, which I'll avoid explaining here, we actually use n-1. So what I'm going to do is divide this by, my sample size is 6, because I have 1, 2, 3, 4, 5, 6 points. 6 minus 1. So 23.5. Why did I write 23.25? I don't know. All right. Apparently I'm better at squaring than adding. So 23.5 divided by 5 is 4.7. All right? We call this variance, and it is a measure of spread. And the symbol is, there's a couple symbols. You might see s squared on your calculator. Well, you won't see it so much, but you'll see this s of x. So that's called variance. The problem with this, okay, so am I done? My measure of spread is 4.7. The problem of this is units are, so the units are pizza squared. What the heck does that mean? Doesn't mean anything. Slices squared, I want slices, not slices squared. So how can I go from squared slices to unsquared slices? Well, the opposite of squaring is taking the square root. So here I'm going to go ahead and take the square root. All right, so the square root of this number is going to be square root of 4.7, which is 2.17 on your calculator. This number is in slices of pizza, because we took the square root. And the name of this is called the standard deviation. And the symbols are either S or S of X. All right? Now, if we're talking about population, so for population, by the way, I would have divided by N if I was doing the whole population. Here, if I was doing population, it's called sigma. So the symbol for a population is sigma. So now that I look at this number, 2.17, does that feel kind of right? Is that about how far apart these points are from the mean? Yeah, that feels kind of in the right territory. It's always going to be a positive number because we're measuring spread. And in our next lesson, I'll get into what does it mean to be 1 standard deviation away or 2 standard deviations away. All right? And we'll also look at the impact of shifting and multiscaling data on standard deviation.